Do you ever wonder what is NFT, what is blockchain, what is metaverse? If answer to any of the question is yes, then let's dive into the video. Hi, this is Rajat Attewal and welcome to my channel. On this channel, I focus on three things. Number one, help you become a Web3 blockchain ninja. Number two, solve climate emergency by promoting sustainable products. And number three, help you decode your life equation so that you can live a happy and meaningful life. So if you're new to this channel, please subscribe to my channel. Welcome back. In this lecture, we're gonna discuss about Layer 2 and Sidechain. In previous series, I've already covered what Web3 stack is all about and what is blockchain. So if you have not watched that, I will highly recommend that you go and have a look on those two previous videos. So in this video, we're going to discuss about the sidechain and layer 2. So basically it's a scaling solution. So in the last video, we covered about blockchain, right? And there is a limitation on the current blockchain, right? So one of that was that you cannot store like large quantity of data, like media files, on it, right? Which you can do in the Web 2 world. But there is other limitation also, right? Because of this decentralization nature, right? So the current blockchain, like I take an example of Ethereum, right? It can process only 15 transactions per second, right? And there is a problem or something called Scalability Trilemma, right? Which I'm gonna go in detail because that would help you understand why we need these layer 2 and sidechain, why these exist, right? So if I quickly draw something, right? So when I talk about this scalability trilemma, right? So there are three things that you need to consider, right? So we looked at this peer-to-peer network, right? Which we call P2P network, which are like containing these blocks of data, right? Which is basically a chain or blockchain, right? Now there are three things that you need to understand in a blockchain system if you want to scale it, right? So the first thing, that property of it is that it should be highly decentralized. When I say it's highly decentralized, it means that, you don't need sophisticated data centers to run a blockchain. Ideally, if you just have a laptop, right? And that's the idea. That's the true power of decentralization, that anyone can be participant in that network. Just like the internet, right? You can just connect it with your mobile phones, with your laptop, right? You don't need a sophisticated hardware to run this technology, right? The second part is the scalability, right? And the third part is the security. So you might have heard about cap theorem also, right? And this is something very relevant if you're coming from a NoSQL background. So it's like consistency, right? Availability and partitioning, right? So in a decentralized system, it's very difficult to have all of these parameters met. So in the current blockchain, right, you will see they're highly decentralized and they're highly secure, right? But scalability is one of the challenges because say for an example, you got 10 nodes in this blockchain, right? To simply scale it, it's a function of number of nodes, right? If I use some big O notation, right? So number of nodes is the number of the capacity of that blockchain, as simple as that, right? If I have to scale it to say 10,000 times, right? So I have to scale these nodes, right, for 10,000 times. That's a simple horizontal scaling. You might have seen that in, some of the database background if you're coming for. But the challenge is that it makes it against decentralization, right? So that was one of the challenges, right? Because I want a very decentralized system where people just with a simple laptop, right, can be participant in that. This limit the scalability part, right? I can't just horizontally scale all of these nodes, right? Or I can't increase my block size, right? Which is another, right? So we have seen that in Etherscan, right? Which I showcased, right? Each block have various transactions. The another parameter is that you increase the number of transactions in that block. Again, that's a security risk, right? So the whole idea of this, there are three ways that you can actually do it. And that's how the overall, the scaling solution look like. There is something on a blockchain level that's been done, right? So like for Ethereum, if I talk about Ethereum 1.0 is there and there is Ethereum 2.0, which is coming. And in that they're talking about like introducing a concept of sharding. So that is like a hard fork within the Ethereum itself, right? Where they support sharding. out of the box. So that increase the current transaction from like 15 transaction to much more on that, right? Also move away from the consensus algorithm, from proof of work to proof of stake. And I will cover a separate session on these consensus algorithm, right? How it works, right? But just for now, just, these are the some of the, improvements that's been done or planned on Ethereum, right? Or various other chains, right? And you will see a lot of debate happening. Like if you compare it with the Avalanche, for an example, that's another blockchain, right? And they say that, we can process much more transaction than, what Ethereum can actually right now. The whole of the scalability solution actually came into picture because of the transaction limitation on Ethereum, right? And somewhere down the line, some of the new blockchain came in like Avalanche or Solana, and they're saying that because we are proof of stake, so we can process like maybe 10,000 or or 15,000 transaction per second, right? And even more than that, right? So there are two ways again, because nobody wanted to change anything within this blockchain, right? Because that would be like fundamentally changing how they operate. And so people have come up with the layer 2 and sidechain solution, right? Because there is a limitation on number of transaction you can send to current Ethereum or any other blockchain, for an example. I'm just taking an Ethereum example because it makes sense, because that's why one of the reason this scaling solution were invented, right? If we had like Avalanche from day one, we could not have been talking about these scaling solution in the way, right? So what they basically did, right? So if I go into the layer 2 and sidechain, right? So because I was not able to do anything on the main blockchain itself, so this blockchain is, think of it as a layer 1, and layer 2 is something that was invented, right? So there are two key options that were invented around it, right? Which we call a layer 2 and a sidechain. So these are completely different. Let me just delete this, right? Now we talked about three ways that you can scale, right? One is on the blockchain itself, right? And I've taken an example of HIT 2.0, which is coming, which is using sharding and everything. The second is a sidechain, right? And the third is layer 2. And these are completely different. So I'm going to talk about layer 2, right? So layer 2, basically what it means is that it's using the security from layer 1, from the blockchain itself. And sidechain is completely different, right? So think of it as like you have these nodes of Ethereum running, right? Or any other blockchain, for an example, and somebody spin up his own child blockchain. It might be using EVM or some other technology, right? Or other proof of consensus algorithm, whatever it is, right? They do all of their off-chain data, the transaction are happening there, and then they submit it to the main transaction. Now this includes a security loophole, because if it's compromised, and again, we discussed about the scalability trilemma. So that is like one of the security risk around, the sidechain. You're doing something outside of the main chain and then submitting some of the proofs on that, right? Layer 2 inherently uses the security of the blockchain itself, right? So there are basically three methods on how this is done today, right? So there is a very good, I would say, article from Vitalik, who's the founder of Ethereum, right? And there are and he goes into detail of this layer 1 and layer 2 scaling, which I've just covered, like sharding and everything. And there are three ways that when we talk about this solution, right? When we're talking about this layer 2 solution, what are the different type of layer 2 solution? There are only three types. So state channel, plasma, and rollups. Even rollup has two type. And so, which is GK and optimism. Again, I would highly recommend that you actually go through it. Link will be in the description of the video. So you go through and it explain in detail like what all of these are and how it works behind the scene. And a rollups, and also a recent article from Vitalik on Ethereum magicians, or where they announced that the rollups is gonna be like a by default standard going forward for Ethereum in terms of the scalability. So all of these are like sort of getting implemented. And this is like under the hood, right? If you really want to understand under the hood, right, how Ethereum actually works, what are the limitations, these are like highly technical solutions that are built on top of it. Most of in the market, you will see Polygon as one of that used. So behind the scene, it actually uses all three, right? So in terms of it actually started for Ethereum, right? But their vision now is that can it be used as sort of generic purpose, scaling solution across various different type of blockchain that are popping up. So I have included one more article which you can go through, and it talks about Polygon scaling solution in detail. But it implements both GK Sync, the Plasma, and Optimism, right? So all of these three things are sort of implemented in there on the solution. So basically, the idea is that all of these solutions are popping up because there are certain transaction throughput limitations because of this scalability trilemma, right? Because how fundamentally the blockchain are designed, right? They have to be decentralized. They have to be very, very secure. So scalability is one of the challenges that you will see in blockchain, along with like storing large quantity of data, which has been like remediated by like using something like file storage, IPFS, which we're going to cover later. But that's the whole idea around layer 2 sidechain, right? So there are three ways that you can do it, right? So the layer 1 is like doing something fundamentally on the blockchain itself, which is like coming up with the sharding concept on top of it, right? Which will be there. And then within the layer 2, the sidechain is completely different, which somebody has spin up, and it's like nothing to do with the security of the blockchain layer itself. The layer 2 solution actually uses the underlying security model, but they are not like, again, there are three types: GK Sync, Optimism, all of that, right? And you can go through the article. So, but that gives you the summary of why these are actually required. So if you understand the scalability trilemma, you will understand why this component is required. Most of the time, you won't be going into the detail when you're working as a web developer or Web3 full stack developer, right? You will probably be using like something like Polygon for an example, which you can use to deploy your contracts. But it's very, very crucial that you understand the underlying principles and the security, because there are a lot of security loopholes. If you go to a sidechain, then you look at the scalability trilemma, and then you understand they are tweaking the security, which is like quite a big parameter if you're talking about a blockchain which is decentralized and transparent. So with that, I hope you like this video. If you like what I'm posting, please subscribe to my channel. That's going to help the Google algorithm and more people can find it. With that, see you. Thanks for your time.